Hello and welcome to the second part for the lecture where we were talking about the Coriolis force. Note, in the previous slide we have discussed the expression for the velocity. We get this as an expression for the velocity. Now differentiating the velocity vector, we get the acceleration vector. So clearly what we are doing over here, we are differentiating, right, the expression for the velocity, and using the chain rule, the first term will get two additional terms using the chain rule. The second contains three terms, and therefore it will have a three differential by chain rule. So we are just writing that. Note that we had also talked about these expressions for the change in the unit vector along the radial directions and perpendicular to that directions. Now putting these two values in this expression, we end up getting the first term remain as it is. In place of dr by dt, we put the value theta dot in theta cap. The third term remain as it is. The fourth term also remain as it is, and the fifth term we put the value for d theta by dt, and we get the value something like this. Right? Now clearly, if we can see the terms can be classified into two parts. One is a radial directions and second is along the theta directions, which is tangential directions. Now clearly, let's understand the terms one by one. What does it mean? Let's use a different highlighter to understand the terms. The first term would be the acceleration due to change in the radial speed. The first one, it is due to the change in the radial speed. Second, we all know, is a centripetal acceleration, and we are familiar with that. The third one is the acceleration from arising out of change in the tangential velocity. The change in tangential velocity would be contributing this term. However, we are not very familiar with this term. This term is the Coriolis force, right? So this is the basically the acceleration which when multiplied with mass will contribute to the Coriolis force, right? Now clearly it has two terms. Now if you see it properly, it is arising from here as well as here. So half the term come from the change in the radial direction, and second is from the change in the angular direction, which is perpendicular to the previous one, right? So this is a mathematical treatment. We have identified the expression for the Coriolis force. In the next slide, we'll talk about how do we interpret this in a physical environment with some live examples. Thanks for watching this video. Continue watching the next one for better understanding.